Hey guys, today I would like to show demo how to perform the secure privacy preserving data analytics using PySpark. And basically in our demo we integrate PySpark with SCONE, allow it to run or process inside enclave. Okay, uh, so I already create the image, namely SCONE PySpark and Zeppelin. So in this image, I'll install PySpark, SCONE, and also Zeppelin, allow us to perform data analytics via the web interface. Uh, as you can see here is I export port 8080 for Spark and port 6868 for Zeppelin. And let's see how it works. First, we need to check our Python is really run inside enclave, and basically in the image I install SCONE runtime and then run with SCONE abide equal to 1 to force the Python run inside enclave. Let's see the script of Python. Okay, so we export SCONE version to see some debug information and also SCONE abide to force Python run inside enclave. So let's check it. Yeah, it seems to be it run with SCONE now. It with hardware mode. We have some branch dusty. So in production, we should change the name. The dusty here is not definitely not a positive word. Okay, let's see. Print TU Dresden. Okay, it worked. In this image, I also create some script to test the system. First, we run Spark. Okay, and then we try to run a very simple PySpark script. Let's check. This script is allowed to calculate bytes values. It's extremely simple. Yeah, now it PySpark run with SCONE, and it calculates the byte number is equal to 3.14. Good. Now we can check the web interface to see Spark system. As you can see, we have one worker here with 8 core. The memory capacity is around 62 gigabyte, and we just run the work is calculate the byte, and the latency to calculate to run the application is 3 seconds. Okay, now we go to Zeppelin to try to perform more complex PySpark script. First, we need to start Zeppelin. Okay. Check it, make sure it really works. All right, it's connect. and okay, let's try to perform some computation via web interface. Create a news, let's say PySpark SCONE demo, and default interpreter is Spark. Let's create one. Okay, so I just get one example from internet for spam classification. Let's put some code here. Okay, so the first step we just import the PySpark with mfleaf with some machine learning algorithm. As you can see here is the logistic regression, support vector machine, and naive Bayes. And I got the two datasets. Also from the internet is the spam data, spam email data, and the second one is a normal email. And let's see what's the inside of this data set. The first line is printing out is the first line that executes the script. Since run inside enclave is quite slow. All right. It seems to be not bring out the first line basically. And next step we convert the text format to the vector feature so that the PySpark can understand the input. Okay, now we got the vector feature. Now we need to the next step we need to convert the to add the label to the dataset. So I add label 1 for the spam data and for 0 for normal data. And maybe we can add the training dataset. Let's see that I execute this script first. Okay. So so label 1.0 here is for spam data and 0.0 is for the normal record. Now let's cache the train data. First we split the data 80% for training and 20% for testing. And then we try to cache train data and the test data in the memory. So 80% and 20% and cache the train data and test data. Excuse it one. Okay, it run quite fast. And then we define a score function that calculates the accuracy of a classification problem. So let's execute it one. Okay. Okay. And then you do that one that define the function, and then we use Let's take the algorithm support vector machine. It algorithm align mode. And then change the data using support vector machine. It will take some time. Meantime, waiting for the training process, I can ask the score model to calculate the accuracy afterwards. I just add command here but not execute it. Okay, already run with 25% finished. Okay. Okay, now the training process done. Now we can calculate the accuracy of the model. Now it seems to be it work. Because we calculate score function we define here is try to get prediction from the model and get the data sets, and we take some time. So this one is we call the testing process or testing phase. We done with more training phase, and now we are performing the testing phase. It also will take some time because it will run inside enclave. Now my computer start make some noise. Okay, let me go and take some tea. Aha, it shows the accuracy already. The accuracy is 88%. It's quite good, right? Another cool thing, let's try with another algorithm with a logistic regression. The cool thing is this system is we can perform several classification algorithm, and then we can compare the performance in terms of latency but also the accuracy. So let's run the training again with different algorithm. Okay, let's run it. Okay, this one is seem to be is the O function. Oh, already finished. This training algorithm quite fast. Now calculate the accuracy of this algorithm. The testing phase it seems to be the same, quite slow. Okay, now we got the result is the accuracy is 86%. So the spot vector machine is provides accuracy is faster, accuracy higher, but uh, it's lower than logistic regression. Okay, now you have an idea how to use SCONE with PySpark to perform the data analytics in the secure and privacy preserving manner. Okay, thank you for watching.